the last session of the day, so thanks for being here. I know it's been a long day. And today, we're going to talk about Orchestrate Generative AI with workflows. My name is Mehta Temel. I am a developer advocate at Google. I'm actually based in London, so because of that, I'm a little bit jet lagged. It feels like 2 a.m. in the morning, because that's what it is in London. This is my Twitter, and this is my speaker deck. So at the end of this session, I'm going to post the slides there, so feel free to go and grab the slides from there. And everything I'm going to show today, they will be available on, well, they're already available on this GitHub repo workflow demos. So everything I show today with the presentation and the demos, they will be available to you if you're interested. So what are we going to talk about today? Well, first, I want to do a little bit of introduction to workflows. I know most of you probably know about workflows or work with workflows, but I want to make sure that we are all on the same page. So I'll just do a quick summary of what workflows is and what it's used for. Then we'll do a little bit of introduction to generative AI. Again, I don't need to explain a lot to you about generative AI. There's a lot of generative AI stuff here today at Next. But I want to look at it at generative AI from an application developer's perspective, what it means to use generative AI as an application developer. From there, we'll get into orchestrating generative AI with workflows. So how you can call and orchestrate generative AI from workflows, and what are some advantages of doing so. And then we'll get into what I call event-driven generative AI. So the beauty of workflows is that it not only helps you to call and orchestrate generative AI, but it also helps you to connect generative AI to different parts of Google Cloud. So I'm going to show you an example of a long text summarization and how you can use EventArc and workflows together to do that. And that will basically show you the power of workflows and how it can be used to integrate different parts of Google Cloud to generative AI. And I also have a bonus section, depending on the time, which is AI-assisted orchestration authoring. So most of the talk is about calling generative AI from workflows, but actually, we can use AI to write the orchestration for us, or at least help us to write it. So we have some features coming up, and I want to give you a preview of a few features on how AI can help us to write these orchestrations to call AI. So it's kind of like AI calling itself in a way, but we'll see. All right, so let's do the introduction to workflows so we are all on the same page. Who is using workflows, by the way? Yeah, OK, some people. So I think it's good to do this introduction so that the rest of the people can catch up as well. So what is workflows? Workflows, it's a service to orchestrate and integrate other services. So you might have some code running on Google Cloud on serverless services like Cloud Run, Cloud Functions, or App Engine. And maybe you want to connect those services to Google or Google Cloud APIs. And then maybe you also want to connect them to some external APIs. So what workflows allows you to do is that it allows you to kind of bring all these together into an orchestration. And I call this orchestration a temporary monolith, because what you're doing is basically you're taking code that runs in different places, and you kind of bring them together in an order that makes sense for your application. But you do that in a temporary kind of way. You're not deploying all these services together. You're just bringing them together with workflows, basically. Now, how you do that? Well, there's a YAML or JSON syntax that you can use. So for example, if you have 3 services like payment processor, shipper, and notifier running on different places like Cloud Run or Cloud Functions, you define steps. So the process payment step, and then you define how to call that service, in this case, HTTP post. Then you also define what goes into the request. And then you capture the result in process result, right? So that's step number 1. Then in step number 2, you have ship items, and you make an HTTP post again. And this time, you are calling a Cloud Function. And then you are passing the result from the previous step. And then you are capturing the result in ship results. So you define what should happen in what order. And Workflows does that for you, capturing the results along the way and passing them to the next step along the way. Now, you might be wondering, why should I bother with workflows? Because I can call these services myself, so what's the point? Well, yeah, you can do that, but once you have these services in different steps, then you can add some control flow around them. For example, if the payment processor fails, you can add retry policies around it. So you can say, I want to make sure that my payment processor, if it fails, I call it 5 times. And I also want to make sure that I don't want to overwhelm my payment processor. So I want to do an exponential backoff kind of retry policy. So you can add that logic in your orchestration. Similarly, let's say your shipper function sometimes fails. So when it's successful, when it returns a success code, you want to call a notification service. But when it fails, you want to call another service, a pager service, for example, right? So that control flow, you can define in your orchestration instead of doing it in your code. And that's a good thing, because you want your code to be about business logic. You don't want to litter that with control flow kind of logic. So you can externalize that with workflows. And then you can do more things, like you can call a database, then get the result. You can check for if something is in stock or not in stock within your orchestration. And then you can go and call a third-party request. You can call a third-party API, a supplier API, and then you can update your database again. So basically, anything that you can call with a REST API and anything that you can represent in a flowchart, you can take that and convert into an orchestration and let workflows handle that for you, OK? So that's what workflows is. So hopefully, it's clear to you if you're not using it. It basically allows you to take the flow of your application and convert into an orchestration and let workflow handle the flow of your application. Now, let's do a little bit of introduction to generative AI too, and then we can get into orchestration of generative AI. Well, generative AI is all about different models, basically, right? We have many different families of models. So we started with Palm. Of course, Palm is a family of models. It's not just one model. We have chat Bison, text Bison. We had code Bison for different kinds of things that you want to do. Then we have ImageGen, the first edition and the second edition. And most recently, we have Gemini, which is a multimodal model with different flavors as well. Gemini 1.0 Pro, Gemini 1.0 Pro Vision, and now we have Gemini 1.5, so on and so forth. But as an application developer, what you care about is basically what model does what and how I can use it, right? I mean, of course, there's a lot of terminology around generative AI, and there's a lot of tech behind it that you can get into. But as an application developer, we really don't need to care about that. All we need to care about is what are the capabilities of these models and how I can call them. So let's actually take a look at a couple of examples here. So here I am in Vertex AI. And in Vertex AI, let's start with the regular Palm-based model. So let's go with a text prompt. And here, let's choose here text Bison, which is a Palm-based model. And we can ask anything we want here. But let's say we just say, where is Las Vegas? Because we are here. And we submit. Now, this makes a call to Palm text Bison model. And then we get this response down here. OK? But if we click here to the get code, we see that there's some code. So we can do this from Python. And by the way, there's this misconception that anything with generative AI has to be in Python. No, it doesn't have to be in Python. Most of the examples are in Python. But there are actual libraries for other languages as well. But here, we show an example in Python. But if we look at the curl, you see that it's basically just an HTTP call, right? So here, we are making a call to an endpoint. And this endpoint has a model ID. So this will be the text Bison that we're calling. And we also are calling it an endpoint. Here, we are calling the predict endpoint, because that's what Palm API uses. And then the request is just basically your prompt and some parameters for the model. So it's basically a curl, an HTTP call to the model. Similarly, if we look at Gemini, you know, Gemini is a multimodal model, which means you can pass in an image and also a text as input. So here we have an image, and the image says, there's a writing on the image, the best dreams happen when you are awake. So let's pass this to Gemini, and let's also read the text in this image as prompt. And here let's choose Gemini 1.0 Pro Vision, which is optimized for images. And let's just submit this. And now we're calling Gemini. So within a few seconds, we get the text down here. So the Gemini extracted the text, and we're good to go. Now, again, if you look at the code, now we again see Python, but you will realize that the Python code here is slightly different from Palm example that I show you. That's because the libraries of Gemini and Palm, they're slightly different, and because of that, the code is slightly different. But they have this similar concepts, basically. We also have examples of Node.js and Java, and other languages as well, but they're not here yet. But more importantly, we again have the curl command. And the curl command is basically just another HTTP call to the endpoint. Now, of course, what you call and what you pass is slightly different, but that's what you find out. You can go to the API reference and find out what the format is and how to actually make these calls, right? OK. So that's basically generative AI in a nutshell. Just, at least for me, it's just an endpoint that I can call, and I just need to care about how I make these calls and what I get back and how I parse the result. Now let's talk about what we actually want to talk about, orchestrating generative AI with workflows. Now let's do this through some examples. Let's start with Palm again. Let's use Palm to get the history of a country, OK? So let's say we want to ask Palm, can you tell me the history of Cyprus? How can we do that? Now I show you that the curl command, so what we need to do is that we need to take the curl command and convert it into orchestration. So let me show you an example of this. So all of this stuff is on GitHub, by the way, so you can check it out later if you like. But if you look at country history, so this is the orchestration. We're going to pass in an argument, which will be the country name. Then we are defining some variables. So here I'm defining my model. I'm defining the method that I want to call. It's Palm-based, so it's predict method. And then I construct my URL, the endpoint that I want to call, with the location and my project and the model and the method. And then once we have that, we are basically just making an HTTP post call, right? So we make a HTTP post to that endpoint. Authentication is handled automatically by workflows. So I just mentioned the type here, but that's it. And then the body is basically the body that I get from the curl command. So I just copy and paste that here. And then I just say, can you tell me the history of the country? And then you can pass in the parameters as well, if you like, with temperature and so on and so forth. So workflow will make this call for us. It will capture the result in a response. And then from here, I just look at the body of that response and get the first prediction, and from there, get the content, right? And then just return that. By the way, I don't know if this is true, but in Palm, it was returning an extra space at the beginning, so I'm just doing a substring because of that, just to get rid of that extra space. So this is how I define it, and then if we actually run this, so this is the same workflow that I have here. Let's execute this. And I will use my last input, so I'm passing the country Cyprus, and then now we execute this. And now workflow will make this call for us, and then pretty soon we should get a response that says the history of Cyprus is a long and complex one, spanning thousands of years, so on and so forth. OK, that's good. But workflows can do better than that. In workflows, we have something called connectors. Connectors are basically small functionalities, connectors that can be used to call other services within Google Cloud. And the point of connectors is that they make it easier for you to call other services, but they also have logic to handle failures and retries and stuff like that. So we have a connector for Palm as well. So let me go back here. So let's look at the same example, but now with a connector. So what I do here is I define the model again, but now instead of creating the endpoint myself, I just make a call to through a connector. So this connector is under AI platform, and then it's using the predict endpoint, because that's the endpoint that Palm uses. So I make this call. The body and the parameters are the same, and then the extraction is pretty much the same, except the response doesn't have a body because it's through the connector. So it's almost the same kind of code, but it's through the connector. And this has the logic of retries and error handling and stuff like that. So if we run the same thing through the connector, so this is the same thing, but with the connector, let's execute that with the same input, and we should basically get the same output like we did before, okay? So instead of plain HTTP, you can use connectors. That's good. Now, that's good for one country, but what if you want to do a list of countries, right? Let's say you want to pass a list of countries and get all their histories. How can you do that? Well, LLMs can understand a list of countries, so you can ask this question, can you tell me the history of Argentina, Brazil, Cyprus, so on and so forth? And LLM will return the results to you. But you have a couple of problems. Number one, how are you going to keep track of all the histories of these countries? So you probably want to return some kind of, you want to provide some kind of formatting information in your prompt and say something like return a map of your countries to histories or something like that, right? You need to think about that. But that's not so bad. But the bigger problem is that the responses from LLMs, they have a limit. So what if you want to get the history of 100 countries, right? At that point, you might run into problems because the response limit might be reached, right? So that can be a problem if you have a lot of countries. To go around that, you can call LLM 3 times. You can say, can you tell me the history of Argentina? Wait for the result, get back. Can you tell me the history of Brazil? Wait for the result, get back, so on and so forth. This will work, but it will take a long time because LLMs, they take a little bit of time, especially if you ask something complicated. It can take 5 to 10 seconds or even more. So if you do this sequentially, it's going to take quite a bit of time. Thankfully, workflows can help with this. So what we can do is that we can use what's called the parallel steps of feature of workflows. So if we look at this example, we have an argument. In this case, it will be a list of countries. And then I'm using text Bison again, but then I'm also defining a histories map that I'm going to keep track of the histories for each country. Then we have this loop over countries step. And in here, we have this magical word called parallel. So in workflows, when you have the keyword parallel, it basically says any steps under here happens in parallel. So what we are doing here is that we are looping through the list of countries, and then we are asking LLM using the connector again, can you tell me the history of this country? And then we are capturing the result, and then we are saving that result for that country into this histories map, right? But the key thing is that all of this is happening in parallel. I think I lost my, there we go. So all of this is happening in parallel, okay? And then in the end, we return the list of the map of histories. So let's actually run this. So this is my parallel workflow. So let's execute. And this time, as you see, I'm passing a list of countries. And then if we execute this, now this is running against like 10 or more countries, but it will take as long as one country because we are running them in parallel. So this will run, and hopefully if things work, yeah, we get the result. So you see the list of countries and the list and history for each country there, which is pretty nice. OK, but so far I show you Palm, and you know Palm is kind of legacy nowadays. Now we have Gemini. So can we do all of this in Gemini? And the answer is yes. Like the Gemini, as I mentioned, it has a slightly different API, and it has slightly different format. But once you go through the reference, you figure out the differences, and you can construct the same kind of thing for Gemini. So let's take a look at that. So I have the same example, but let's look at the Gemini version. So here, I'm using Gemini 1.0 Pro. And then I'm using the parallel steps again. And then the difference is that here I'm using a different connector. So in Gemini, the endpoint is not called predict, it's called generate content. So I need to remember that. And also the body is slightly different, right? So we have this user role, and then you have to pass the prompt in a place called parts. And then generation config is the configuration. It's slightly different syntax than Palm. But apart from that, it's pretty much the same kind of code, right? And then the way you parse the response is also slightly different. So here we have candidates, content, and parts. So you have to pay attention to these details, but it's not so bad, OK? So if we run this, so this is the Gemini version. If we run this, now we are running against Gemini. And hopefully, we'll get better results because Gemini has a more rich model. So the results should be better, hopefully. So we'll let that run, and then we get the results. And yeah, you see, I think it's in Markdown or something like that. So there's more stuff in there, hopefully. All right. But Gemini is about multimodal, right? So you can pass in images to Gemini, and it gives you results for that. So for example, can we do something like this? Like, can you describe this picture and pass in this picture from workflows? And yeah, the answer is yes, you can. So in this example, so let me go back here. Describe image. Here again, I'm using Gemini 1.0 Pro Vision because I'm going to use this for images. So for that, I should probably use the vision model. And I'm using the Gemini connector. And then the body will be slightly different. I'm passing the image URL. The image lives in Google Cloud Storage bucket. And then my prompt lives here, describe this picture in detail. And then we capture the response, and we parse it the same way. So it's very similar to any other kind of call, except we have this special part where we pass in the image URL, OK? So if we run this and pass in an image URL that lives in a Google Cloud Storage bucket, then the output, the image description says there are several bluebird scones on a table. One scone has a small silver spoon on it, so on and so forth. So that works as well. So this is basically how you can call generative AI from workflows and how you can parallelize them and how you can also add error checking around it using the retry policies of workflows. So that's pretty straightforward. But the beauty of workflows is not to make these calls, but to make these calls and connect generative AI to other parts of Google Cloud. So in this example, I want to show you one example of that. And it's an event-driven example where an event triggers a workflow, and the workflow does the generative AI calls and gets the results. And that example is about a large document summarization. So let's imagine that you have this large document, maybe a book, and you want to use generative AI to summarize that. Normally, if you are using Gemini 1.0 or Palm, you have a limited context size, right? So you can't pass the whole book and get the summary of it. So you need to do something special. In Gemini 1.5, the context size is much larger, so you can probably pass in the book if you like, but it will probably be expensive also, like to upload that and also to run it, right? So let's forget that for a minute, but let's assume that you have a small model and you want to do this large document summarization. How can you do that? Well, one way of doing that is what's called a map-reduce summarization. So the idea here is that you have this large document that you cannot pass to the generative AI because it's too big, but you can divide that into small chunks, right? So you divide that into n chunks. Then you call Gemini and ask Gemini, can you summarize these n chunks for me? So you will get n summaries. And then you can call Gemini again and make a summary of the summaries. So you say, can you summarize all these summaries? And then in the end, you get your final summary, right? So it's kind of like a map reduce of summaries. And the beauty is that workflows it can parallelize these calls for you. So it can parallelize this part, and it can also parallelize that part, and in the end, you get this final summary. So that's number one. And the second part is that you can use workflows to also connect this to some kind of events. So for example, you can have the user drop the large document into a cloud storage bucket, and then have this generate an event. And that event goes to workflows. And then workflows will do these parallel calls. And then in these parallel calls, in each branch, we will read from the bucket a part of the file. Then we will call Gemini and get a summary. And then once we have all these summaries, we will call Gemini again to get the final summary. So the idea here is that workflows helps us with the parallelization and orchestration of these calls, but it also helps us to connect this to something in the Google Cloud, in this case, an event from Google Cloud Storage. So how can we do this? I have it here. So let's go here, parallel summaries, and parallel summaries connector. So here we have an input, which will be an event, a Google Cloud Storage event. And then from the event, we figure out the size of the file, how big is our document. Then we need to decide a chunk size, so how big we want each chunk to be. We don't want too small chunks, because if we have too small chunks, then we're going to have too many parallel threads. But we don't want it too big either, because if it's too big, then we're going to run into problems with the memory in workflows. Workflows has a memory limit as well. So in this case, 64K is a good chunk size that you can use. And then with that chunk size, we can get the number of chunks that we have for our document. And then we initialize some variables that we're going to need later. And then we do our trick again. We do our parallel steps. So we go through each chunk. Then each chunk figures out what's my lower bound, what's my upper bound in the document. And then we use the Google Cloud Storage API to read parts of the file. You don't want to read the whole file again, because again, you're going to run into memory problems. But here we are basically reading the part within the file for our chunk. And once we have the file, we call Gemini and say, can you summarize this for me? We have a sub workflow to do that. And then once we have the result, we save that summary to a list, OK? At this point, we run our parallel summaries. We get all our summaries. Then we loop through them, and we concatenate them into one big text. And then we reduce that into a final summary. So we ask Gemini again, can you summarize these summaries? And we'll have the final summary. And if you look at the sub workflow, it's basically the same code as before. We are using Gemini Pro, and we are using the connector to make these calls. The prompt is a little bit more detailed here. I'm saying, make sure that the output has only plain text with no newline or return characters. You need to play with the prompt to get the right kind of output. And then I'm also blocking some safety settings so that nothing is blocked. But you shouldn't do that. You should probably block the text. But for the demo, it's OK. And yeah, that's how we do it. So here I have the bucket where I have my text. So I'm going to upload the Pride and Prejudice book. And then I have the trigger that connects the event to workflows. And then I will have my workflow here that I already deployed. So let's actually upload a file and see how that works. So I'm uploading Pride and Prejudice, the full book. And I already have it in the bucket, so I'll just overwrite it again. And now this should fire the event with event arc. That event goes to workflows. And we should see here a new execution. You see that there's a new execution happening. And now this is doing the parallel steps. And actually, if we go here and if you look at steps, you'll see that there's a lot of parallel things happening that you can actually get into and look at them. And if something fails, you'll also see it here. So things are running. I don't want to wait for that. So let's just look at the results from my previous run. So if you look at the previous run, you see that the input is just an event. And then the summaries, so the output will have a list of summaries. So these are the summaries of roughly each chapter in the book. You see, I won't go through them, but you see a list of summaries. And then you also see a final summary where it says, Pride and Prejudice is a novel by Jane Austen that follows the story of Elizabeth Bennet, a young woman who is prejudiced against the wealthy and proud Mr. Darcy. I don't know. I haven't read the book, so you tell me. OK. So that's it, really. So I just wanted to give you a flavor of how you can call workflows, generative AI from workflows, how you can do these parallel calls, and what are some benefits of doing so, and how we can help that with the connectors and stuff like that we have. And now in this last part of the talk, I want to talk about some AI-assisted orchestration authoring that we've been working on, and some features that we have there. And we also would like to get your feedback on this at the end of the session. So let's look into that. Now, authoring YAML and JSON for orchestration is hard, right? I don't like working in YAML, but that's what we have in workflows for now. But thankfully, AI can help, and we've been working on some features that's going to be available soon. So I want to show you a couple of examples on this. First, let's say, let me close these. I don't need them anymore. Let's say I get this parallel summaries that I show you, workflow, from a developer, and I'm looking at it at the first time, and you see there's a lot of code here. I need to really read through it and try to understand what it's trying to do. So one of the features that we are working on is that we have this new thing here that has explain or summarize workflow, right? So summarize workflow will call Gemini, and it will pass the workflow, and it will give us a quick summary of what this workflow does, right? So we see here that the summarize workflow says this workflow takes a file from GCS, splits into chunks, and then sends each chunk to a Gemini model to generate a summary. The workflow then concatenates all the summaries and sends the concatenated summary to the Gemini model to generate a final summary. So that's pretty good. And then it also gives you, like, what's the input, what's the output, and what are the hard-coded values, stuff like that. So with that, you get a quick summary of what the workflow is trying to do. Now, if you want to do a more in-depth explanation, you can use explain workflow. And this will basically do the same thing. It will send the workflow to Gemini, but this time you will get a more in-depth explanation of what each step does. So it's very useful if you are not familiar with YAML and you want to get a quick understanding of what this workflow does. It can be useful for that. So if you look at the explain workflow source code, you see that it goes through each step and explains each step in a natural language kind of way. Okay? So that's one thing. And the other thing that we are working on is when you author a workflow. So let's say you are creating a new workflow. And this is the hello world workflow, but let's just erase this. And let me make this a little bit bigger. So here, let's say I'm writing a new step. And I will, let's say I want to get access to some storage file, Google Cloud storage file somewhere, right? So I'll just say get storage object, right? So that's the name of my step. But I don't remember the syntax of how to access to the Google Cloud Storage bucket, right? So we have this new section called Quick Help. And by the way, this Quick Help is there right now, but it's once we release it, it might not be here, it might be in a different place. But for demonstration purposes, this is where it is right now. But if we click here, now Gemini is suggesting us some things. Like here, the first suggestion is the Google Cloud Storage connector, right? Because it kind of figured out that we are trying to access the Google Cloud Storage. So if we expand this, you see that you get an example of this Google Cloud Storage connector. You can see the arguments that you can pass in. And then you can also see what the response needs to look like. That's very useful. Similarly, if you want to remember the syntax of workflows, you can type syntax cheat sheet, and this will look at our docs basically, and then it will give us some examples of numbers and lists and maps and expressions and so on and so forth, and you can copy and paste them and use them in your orchestration. We were doing Gemini calls, so if I want to do how to call Gemini on Vertex AI, then it gives us the connector call again, and then it gives us examples of Gemini Pro and Gemini Pro Vision, which is pretty cool. And for me, one of the most useful things is that it also gives me some links to documentation. And if I click to one of them, Vertex AI Generic Content Method, it takes me directly to the reference page for the REST API, right? So if you're a developer, you know sometimes you spend 10, 20 minutes just to find the right place in the reference docs where the endpoint is and how to make the call. But with this, you get direct access to that right away, which is very useful. And finally, if you do something like how to do parallel steps, because that's what we were doing, you again get this parallel examples. It talks about parallel for, parallel branch, and it gives you access to the documentation, so on and so forth. So that's very useful as well. All right, so these features that I explained, explain and summarize workflow, the quick help that I mentioned, and the Vertex AI connector, they're all coming to workflow soon to preview. So they're not available yet, but they will be pretty soon. So if you want to hear about them, please join to our group, Workflows Insiders, where we announce these features, and we also have discussions there once in a while. So feel free to join. And the Workflows team, they're looking for your opinion and your feedback on what we should do. So if you want to share your thoughts, this is the QR code. And I also, I also have this postcode that we're going to hand out on the way out. So on the way out, please, if you want to give us feedback, collect one of these. We would really appreciate. And I also appreciate your feedback on the talk. So please do that so I can read it later and improve the talk. And that's it. Thanks very much for staying. Thank you.